Welcome to the third and last pointer problem that we'll be covering in line 75. And this problem is called the Max Water Container, or simply speaking, the more common name for this problem is a container with most water problem, right? And the general goal we have here is that given an array of numbers, we build a bar chart, simply speaking, of the array of numbers and then find the two bars with the highest height, which can contain the most amount of water within, right? So what do you mean by that? So let's our whiteboard and let's say we have, let me take green here. We have a simple bar chart here, right? Trying to be very clean about it, but like we have a simple bar, right? And then we have different based on that array above that we see, based on this array here and these numbers here, we build out bars for each individual number in this particular array, right? And these bars look like something like this, you know, different sizes. This might be the same, or some might be smaller, some might be medium sized, so on and so forth. So that is basically what I mean by a bar chart. So once we have all of these numbers here, uh, once we have all of these numbers here, see in the bar chart, then we need to basically identify which two bar charts uh, can store the most water based on their area, or even simpler than that, which two bar charts, when combined with their base and their maximum height of one of the highest bar chart, if one bar chart has a higher height than the other, then the one with the lower height would be considered between as the area of the height, right? So based on that, we need to find the bar chart, two bar charts with the highest area in them. That is our problem. We need to find a bar chart with the highest area. With that main question out of the way, let's move on to actual bar chart here. So first way we could do, and I think we've discussed the two pointer problem. So we have two pointers, the left pointer, which is red, and then we have the right pointer, which is green. We have these two pointers here. We have these two pointers. And between these two pointers, there are two ways to solve this problem. So the first way would be we just we do two pointers, uh, and I'm just going to use a dot to represent the right pointer, right? Let's forget that the right. So red color is right, sorry, left, and green color is right. So we have one pointer over here, right? And we have the second pointer here, right? So once we have these pointers, right, based on that, what we do is we have these two bar charts that we have created this bar chart out of the length, the height that we got for each line in that array. So these two, if we're talking brute force method, we have these two bars. So we draw the line from the, not draw the line, but we consider the height of the be the lower of the two bar charts and find the area of this area place, right? So this is the area we try to identify. See, but and we stored that value here, right? And we've gotten the area of that particular place. So let's say it's one at the base and one at the height. So the area here is one. Clear. So the area here could be one, right? Similarly, if our area, if our and brute force method would be that we do it for all of these here. We keep the left pointer as is. We change the pointer, the right pointer, to the next one here, and we do the same thing here. So again, the lower height is the one of the left pointer, so the height remains the same. The area though doubles, right? And then we find the area for this area, right? Similarly, pointer could move and say, move here, and then we record the area of the next pointer here, so on and so forth, until we go to the last pointer here and find the area of this entire area. Again, the height is of the lower one, which is still 1. It's a little imprecise, based on the fact that, I've done this quickly, but, something like this, right? This entire area is covered, and we get the area of that portion. Once we're done with this area, then what we do is the red pointer to the left here, and then do the same with the rest of the ones here. First, to find the area of this area, which is this and this, the lower of which is the right pointer. So this is the area we find, and find the area of this area. Then we do it this one here, so on and so forth till we reach here. The right pointer reaches here, and we do the area for this entire area, which is the right answer. But again, like uh, you know, as we talk about, uh, uh, as we talk about brute force method, one by one through all pointers, the right pointer covers everything, right? There's that way. But again, like, and if you've watched our previous videos on two pointers, you'll notice there's another method, probably a more simple method to do that, because this particular method that we just went over, the brute force method, gives us a time of O of n squared, which some interviewers might allow to you to or might accept the answer of that method and that speed, but some might not. So the best way is to learn the method which is accepted probably everywhere. And so based on that, we can have two pointers here: the left pointer here and the right pointer here. Right. So first we check the area between the area. The lowest of these bars is the left pointer. So we take the left pointer as the height, and anything and the distance between them as the base between these two bars, right? And calculate the area of this area and in a save that within a data structure where we say area of first the area of the first test is certainly certain number, right? Whatever that is. So once that's done, then we we see which of these two is the limiting factor. By limiting factor, which one is limiting the size of the area? The base is the longest right now, not the base, but it's definitely the height that we need. So the height of the left variable is smaller than right variable. Then left variable, the next to the next to the next to the left to the right of it, right? The left pointer moves here, and here the base height is this. We calculate the area of this area, this area, and then we see what is the limiting factor, and then we move on. Left remains where as is, and the right one area moves its left, basically. The right pointer moves here, and then we the limiting factor is the right, and then we cover all of these until they reach the natural stopper each point for two, which is when they overcross each other, basically. So with that out of the way, I think we get the idea of how this is going, right? And what the good thing about this solution is that the time complexity for this solution is n, which is the ideal time complexity we need for these answers here. And that's the lowest time complexity we can this particular. So I think with that out of the way, let's move towards solving this problem, figuring it out. So we need to find the max area or the container with most water within these heights of arrays, the array heights that we've been given. So, uh, how do we solve this problem? So there we obviously use the two-pointer, and we've gone over the methodology there. So let's go over our approach. The three problems that we solve. One, we need to start with two. at left of the array and one at the right of the array. At each step, we calculate the a and number two. At each step, we calculate the area of the container of left and right. The area is determined by the shorter of the two sides multiply the distance space. And number three, we move shorter height inward and would increase the upward. Moving shorter one might increase it. So with that out of the way, let's start coding the problem out. So first, we need to define the different pointers, right? And again, we're going to, um, you know, define that. So then left is obvious, and right is length height. That's the variable we have. Indexes are the starting point. Once that's out of the way, the next thing is to define the max water is a certain uh, set its value to 0. Then, as usual, I think we move towards one of the most while loop that determines their exit condition, where left is must be less than right. That's the exit these pointer problems. Then we bring on our first pseudocode, our first pseudocode here, which is to calculate the width between the two pointers, right? So that is something we need next, and we write it down there, so we know what we need to do. So the width between the two pointers is obviously right minus left, and that is the base. Right is going left. That is going to be the base for us, which we're going to calculate the area. Then we need to find the height of the shorter line. So which of these two is the shorter one? Is using the main built-in function in Python. So we say h, which is our height variable that we need to create, uh, height variable that we need to create we need to set that up. So first is uh, basically height of left, heights of that is. After that, we need to calculate the area of the area and update max water. So, and then compare our current area with the current value. What we do is we re-update the value in max water, which is the variable that's stored. That up that compare the updated the area of the current height and width with the existing value in max. The area of larger than the current value of gonna update the value of max water to the current value. But if the value of max water is higher than the area of the current value, then obviously max water is going to remain. That out of the way, the next thing we need to look into is how to move our pointers. So a pointer is those left and right pointers that we sorted out. So we need to move the pointer that points to the shorter line, basically, right? Tells us to do. So we here, and then we set up the system through which we move the pointers left to right based on our process, right? So if height of is height of left is smaller than height of right, then we move the left value inwards or to the right. Have heights of right, then we move left, else right to left. After that, we value. That should be our OFN solution for this problem. That's the third problem for pointers. So let's run our solution, and it tests positive for both cases of this problem. And that means we've solved this problem correctly. And with that, we'll wrap up this video and see you on our next video on line 75. Thank you.